Welcome to another lesson of Math 0420, Introductory Algebra. In this video, we will be discussing section 3.5, the point-slope form of the equation of a line. In this section, we will use the point-slope form to write equations of a line. Let's get started with a definition. Definition. The point-slope form of the equation of a non-vertical line with slope m that passes through the point x1, y1 is y minus y1 is equal to m times x minus x1. So basically what this tells us is that we can find the equation of a line given just a single point on that line and its slope. So we can plug in the x value and the y value of a point and the slope, and we can find the equation of any line. Let's try an example. Example 1. We want to write the point-slope form and the slope-intercept form of the equation of the line with slope 6 that passes through the point 2, negative 5. Now let's remember back to our previous slide that the point-slope form is y minus y1 is equal to the slope m times x minus x1. Okay, so what's our m? Well, our m is our slope, so that's 6. And x1, y1, our point that goes through in that line, is 2, negative 5. So we can plug those in. So y minus our y value, which is negative 5, is equal to m, which is 6, times x minus our x value, which is 2. Okay, right here, that is the point-slope form of the equation of the line. Okay, now to find the slope-intercept form, we need to solve for y. So we can simplify the y minus a negative 5 to y plus 5. Oops, not y, plus 5. We can distribute on the right-hand side. 6 times x is 6x, and 6 times negative 2 is negative 12. Then we can subtract 5 from both sides, and we get y equals 6x minus 17. Negative 12 minus 5 is negative 17. So this is in y equals mx plus b form, so that is the slope-intercept. And so now we can see from the slope-intercept form that our slope is still 6. That didn't change, and we shouldn't expect it to. And our y-intercept is negative 17. Let's try another example, but this time we'll only be given 2 points. Example 2. We want to find the equation of the line that passes through the points negative 2, negative 1, and negative 1, negative 6. Now you may be asking yourself, well, this is not the point-slope form. Well, you're right, because we're given 2 points and not a point and the slope. But in a previous lesson, we learned that the slope can be found by using 2 points. So we can find out that the slope is y2 minus y1 divided by x2 minus x1. Okay, so we can now plug in our values from those points, and we can do negative 6 minus a negative 1 divided by negative 1 minus a negative 2. Now remember that when you start with the -6, so this point, you then subtract the y value of the other point, and then in the denominator, you have to start with the same point, the second one, and do -1 minus a -2. Okay, so -6 minus -1 is -6 plus 1, or -5. And -1 minus a -2 is -1 plus 2, which is 1. So our slope is -5. So our m is -5. Now that we have that the slope is -5, we can use the point slope form, which is y minus y1 equal to m times x minus x1. So we can pick either point to go in for our x1, y1. I'll do -1 and -6. So we say y minus our y value, which is -6, is equal to our slope, m, which is -5, times x minus our -1. Okay, so we can simplify that. That's our point slope. We could stop there, but we're going to move down and do the slope-intercept. So we get y plus 6 is equal to -5 times x plus 1. And that's because x minus a -1 changes to x plus 1. Then we can distribute the -5 to get -5x. -5 times 1 is -5. And then to solve for y, we can subtract 6 from both sides, and we get y is equal to -5x. -5 minus 6 is -11. So if we are given 2 points, we can follow the following steps to get the equation of our line in slope-intercept form. All right, step 1, we find the slope. Then we plug into the point slope formula. And then finally, to get into slope-intercept form, you solve for y. Okay, so far we've talked about a number of different forms, and so the remainder of this section will be devoted to describing those forms and reviewing them and talking about what you should know about those forms. So there's the standard form, y equals b, x equals a, slope-intercept form, and point slope form. Okay, let's go over those now. And this table is fairly useful. It's got 2 columns, the form that we're looking at with regards to the equation of a line and what you should know about that line. You're welcome to pause the video and write this down and have that the table for you. There are, let's see, 1, 2, 3, 4, 5 different forms we'll talk about. And so you're welcome to stop the video at any time and write this down, but I'm going to go over each of these and review them and what you should know. The standard form of the equation of a line is the form ax plus by equal to c. And the easiest way to graph equations of this form is using intercepts. So to find the x-intercept, you set the y equal to 0 and solve for x. And to find the y-intercept, you set x equal to 0 and solve for y. And then you can find a separate checkpoint that is not those intercepts. And then you have the form y equals b. If you have an equation of the form y equals b, that's always going to be a horizontal line, and b is your y-intercept. So anytime you have y equals a number, it's a horizontal line, and whatever that number is your y-intercept. If you have an equation of the form x equals a, well, that's always a vertical line. A vertical line will have a as the x-intercept. Something else that I want to tell you about y equals b and x equals a. If you have a horizontal line like y equals b, your slope, notice there's nothing in front of x, there's no x on this side of the equation, so your slope is 0. For a horizontal line, your slope is always 0. On the other hand, for a vertical line, x equals a, you do not have slope. It is undefined. Okay? Let's now move on and talk about the other two forms of the equation of a line we've discussed, which are slope-intercept and point. Again, you're welcome to pause the video at any time to copy this down when you're ready. The slope-intercept form, again, is y equals mx plus b, where m is our slope and b is our y-intercept. So to graph equations of this form, you use the y-intercept, which is b, and the slope, which is m. You start with this form when you're writing a linear equation if you know the slope and the y-intercept. If you know the slope and the y-intercept, you can immediately just write the equation. Okay? That's probably the most common form that we use because it is so easy to visualize what the slope and the y-intercept are. Okay, point slope form. We just did this one in this section. It's y minus y1 equal to m times x minus x1. And you start with this form when writing a linear equation if you know what the slope is and a point on the line not containing the y-intercept, or if you have 2 points on the line, neither of which are the y-intercept. So we can use that to find the slope. Okay? So again, x1, y1 is our point, and m is our slope. One more set of information I want to add for point is that if you are given 2 points on the line, you can calculate the slope using the formula m equals y2 minus y1 over x2 minus x1. That's taking the difference between the y values in the numerator, that's our rise, and the difference between the x values in our denominator, and that's our run. And although that you may begin with the point slope, you usually solve for y and convert to slope-intercept form because, again, that is an easy way to see the equation. Okay, that is the conclusion of section 3.5, the point-slope form of the equation of a line. Good luck on your homework. Please let me know if you have any questions as you're going through it, and I will see you in the next